What is meant by series and parallel connection of resistors? This figure shows the series connection and this is the parallel connection. Here R1, R2, R3 are connected in series. So same current I flows through this circuit. Same current I flows through R1, R2 and R3. But here in parallel connection, the current is splitting from this point X and I1 part flows in R1, I2 part flows through R2 and I3 part flows through R3. Here the PD across X and Y is same, that is PD across R1 equal to PD across R2 equal to PD across R3, but here the PD across R1, R2 and R3 are different, but here the current is same, PD is different. Here current is different and PD is common. You just consider this problem. Draw the diagram for 3 cells of 2 volt each. A 5 ohm resistor, an 8 ohm resistor and a 12 ohm resistor. Then a voltmeter, ammeter and a plug key all are connected in series. Then we have to find the total resistance of the circuit, the current through the circuit, that is the ammeter reading, then PD across each resistor. Then we have to prove that the total potential difference across the combination of resistances in series is equal to the sum of potential difference across the individual resistors. So here 3 resistors R1, R2, R3 are connected in series. So what is the series combination? First one R1, R2 and R3. This is the series combination of resistors. Then it is connected to the cell, that is a 6 volt cell. 3 cells means 2 volt of each cell. So 3 into 2 equal to 6 volt. Cell is connected. Voltmeter, ammeter is connected. So we have to find what is the effective resistance. First question is, what is the effective resistance of the circuit? So R is equal to R1 plus R2 plus R3. So this will be equal to 5 plus 8 plus 12, because R1 is equal to 5 ohm, R2 is equal to 8 ohm and R3 is equal to 12 ohm. So this is equal to 25 ohms. So that is the answer for the first question. Then second question, what is the current I ampere passing through this circuit? By Ohm's law, we know that this V is equal to IR. This is Ohm's law. So what is I? I is equal to V by R. V is equal to 6 volt by R is 25. So you are getting the result 6 by 25 is equal to 0.24 ampere. This is the first answer, this is the second answer. And third question, what is the PD across each resistor? So can you say the potential difference across resistor R1, we can call it as V1. V1 equal to IR1, that is I, we have to find I. So I is equal to 0.24 into R1. R1 is 5. 0.24 into 5, that is equal to 1.2 volt. Similarly, the PD across the second resistor R2, can be written as V2 equal to IR2, that is I is 0.24 ampere into second resistance is 8 ohm. So this will give you 1.92 volt. Then third, PD across resistor R3, by Ohm's law it is V3 equal to IR3, so that is equal to 0.24 into 12, so this will be equal to 2.88 volt. Then in the fourth part we have to prove the value of V1 plus V2 plus V3 equal to the 6 volt, the total volt. So that is, what is it? So it is equal to 1.2 plus 1.92 plus 2.88, which is equal to 6 volt. That is, we have proved that V equal to this V equal to V1 plus V2 plus